So hello guys, what's up? We are back again with another question from our DSA challenge series. So let's get started. So guys, today our question is construct a binary tree from a given pre-order and in-order traversal. Now, okay, so we are given two arrays, pre-order and in-order, and we need to construct a tree and return its root node uh whose pre-order and in-order traversal is given to us. Okay, so what is the intuition behind it? Now, what is a pre-order traversal? Pre-order traversal is something in which we print the root node first, then we go to its left subtree, and then we go to its right subtree. So the pre-order traversal, we can say that we can have something like in a sorted order in which we will first print the root, we will then go to the left and then go to the right. And what about the in-order traversal? In-order traversal, we go to the left, then we come back to the root, then we go to the right. So this way in-order traversal works. So we will use these properties only. What we can do is we can use the in-order traversal. Okay. First, we will use the pre-order traversal. We will find that particular, okay, so that will be the root. We will create a, of course, we will make it a recursive function. So pre-orders index will be the root. Now roots left will be in order. So we will find that index in the in order traversal, and then that left part of that will be the left part of that root. So that will be the left subtree. And the right part of, for example, here we can see that here if we take 3, so left of 3 will be what? In order travel will be left subtree of 3 in the in order traversal, and right of 3 in the in order traversal will be right subtree of 3. So we will use this property only. For example, 20. So we will find 20 in the in order. So 9, 3, 15 will be left of 9, 3, 15. First, they have already occurred. But 15, for instance, is in the left of 20, and 7 is in the right of 20. So yeah, in this way we can do that. So let's see the code. So we have written a function f in which we are taking the pre-order, in order, and the index, which we will use to iterate the pre-order array, and starting and ending index, which will give us the range in which we need to serve, in order search in order to find the range of in order traversal. Okay, so very simple. If s is greater than e, that means we have reached the root node, sorry, leaf node, and then we have to return null. And if index somehow crosses the in order dot size, then we will return null. So if the index crosses the boundaries, then we will return null. Okay, so in order dot size or pre-order dot size will be same. So you can write either of that. Now we will find the index. We can use a find in order function, or we can implement it using map as well. That's not that much issue. Now we can find the index in the in order array in which our this particular index element is there. Okay. So then we will find the root node using the standard new method, and then we will call for roots left and we will call for roots right. Finally we will combine and return the root. So yeah guys, in this way we can solve this question. Find in order is very simple. We have the index and we have the in order and pre-order array. So we'll find out in which index the to find is pre-order of index. So in which index in order traversal that particular element is there. So yeah guys, in this way we can solve this question. Thank you so much guys for watching this video. Just in case you liked the video, you liked the question, make sure you hit the like button, press the subscribe button, and share it with your friends. Thank you so much guys. We shall see you next time.